Good morning once again. I'm Joseph Tishimire, calling you from Rwanda, on behalf of the Africa. Now we are continuing with our training series that was organized in collaboration with the Nigerian Space Research and Development Agency. Today it's uh, our fourth session. That's we focus mostly on the monitoring of urban expansion and the coastal erosion. And tomorrow we'll be concluding by the development of edge case. And before I get started, I've shared you in email an evaluation form. I put it in the chat once again. That's the part to capture your feedback, but also will be from the database to design certificates that will be shared tomorrow by the end of the training. Please feel free to fill the form and we'll get the certificates at the end of the training. Uh, Once again, if I go back to the presentation, so today we'll be focusing on the urbanization and the monitoring of the coastal trends across around the continent, especially the focus on Nigeria. Also, I acknowledge the support of Kenneth Mubeya, who is not here today. So, once again, the Africa is providing a free access to Eagle data, related cloud computing infrastructure, and also capacity building that's to empower governments in the technologies across the continent. Everything is free, co-developed, validated, and disseminated in collaboration with our partners. We thank different space agencies, especially the USGS and the ESA, for providing access to free data that we process and host in analysis ready format. And of course, everything is free, and you can always um, uh, feel free to explore our online learning platform that equips you with the basic skills to use our machine learning and artificial intelligence for the processing, analysis, and visualization of Earth observation datasets. So all the notebooks, a lot of tools were developed. They are freely available either via our sandbox, or even you can access them via the GitHub repository of the Africa, and either can customize them or you can even specify a time scale and the spatial and then run your analysis immediately. So among the products, we've covered all these products you can see here. And today we'll be mostly using this GeoMads and the coast lines monitoring tool that inform urban change and also the trend of the coastal erosion and also impacts on both the coastal infrastructure and also and the coastal ecosystems. So we'll be using mostly two interfaces. The first one will be the Africa map, and the second one will be the sandbox, which is a robust cloud computing infrastructure. It's free. You just need to have an account and start enjoying both the cloud computing space, uh, our pre-developed tools, and also uh, different advantages. Once again, it's a temporary working environment. You should always back up your notebooks to keep your changes once you have to log out of the sandbox. So Now, the first part, we talk about urbanization, and the Africa had developed several notebooks to monitor urban trends. Among them, we can mention one that uses the enhanced anomaly different behaviors surface index that try to understand the trend in urbanization, but also we can compare different indices that to understand also which suits to any of our urban areas. And mostly we're using Sentinel 2, Sentinel 2 annual geomat, but also can equally use Sentinel 1, which is radar, and also some global data sets like the global settlement footprints and others, as you'll be seeing them in the demonstration. So when you go into a sandbox, we have a lot of notebooks. Among them, we can highlight one on urban change detection, another on urban index comparison, and high resolution population density, or settlement footprints, and so on. And these are free available. And as you know, the Africa, we could develop our own services and products, but also we judge better to index data and services from other providers so that we could kind of serve as one-stop center, data center, and that's what you do to run most of your analysis. So we can try to understand the urban change detection and try to see how the urban area have been evolving uh, over time. And this is a cost-effective tool for accurate uh, urban mapping. That's also it helps to cover large areas without necessarily being uh, on a field. So there are several notebooks in the sandbox, but once again, if even we go through video interpretation, if you go into a digital Africa maps, so of course I always post the link in the chat. If you like to go together with myself, you can zoom to Nigeria. Let's say we go here around Lagos. We can just for simple explorations, we can go to our data sets. You can go to our annual geomats. Let's go for Sentinel geomats. And this is the geomats for showing how Lagos looks was looking like in 2024. That's 2017. We can even do a simple comparison as 2017 and 2024. Just visually, you can slide to see how in 2017, 2024, 2017, 2024, 2017, 2024. You can see how these areas here, if you go to 2024, they have been connected by buildings. The same for this now, now, now eastern areas, even here, down here along the this lagoon, the city has been expanding over time, a kind of buildings increasing, but also, it's a dense city, and the it may change slowly compared to other rapidly growing urban areas. Um, I was looking for Ibadan, so that it is rapidly growing city with a high academic infrastructure. And if we keep the same comparison for our study area, It may take longer to load, but let's be patient. Um, so because we're displaying a mosaic that covers all continents at 10-meter resolution, and it seems heavy. That's what takes longer to display, but also it depends upon the connectivity. This is 2017, 2024. Yes. Left 20, this 2017, 2024. 2017, 2024. Can you see this southern part has really been affected by urban growth? The same applies for these uh, uh, northern areas, and you can keep exploring however you want using the Africa maps. And of course, this was from the Africa uh, product, but also uh, there are other global uh, datasets that we acquire from the providers. If we start data, we have this Africanopolis uh, green space. Also, they help us to monitor the urban greeness, if you can see, and also it gives a lot of information about urban expansion for several cities across the continent, and also it shows us about the size of green spaces for each city, and you can compare. They have 2015 and 20 2020. Actually, those are few ways to view urban growth in general. But if we go back to our sandbox, we have a way to compute different indices to monitor the urban trends. So we can use Sentinel-2 just to use the ENDC to calculate, to monitor the urban change, urban dynamics for a given region. So this is the formula that used to calculate the enhanced number difference impervious surfaces index. And from here, I try to work for Abuja. We have a notebook that will show us how the city has expanded over time. Any question, please? Feel free to ask the question. Oh, great. Thank you. So if I go back to our sandbox once again, if you go into the sandbox, you go once again to the real world examples. There is a notebook that's called Urban Change Detection. Please ignore the notebooks. I've been creating them. I'm training lot of people. Urban Urban Change Detection. This notebook, you just duplicate it, and if duplicating it, you can open it, and you see this. You look at this. It will be Urban Change Detection. Let's go together if possible. And this notebook, as I said, it is using the enhanced difference impervious surfaces index, and it shows us the rate of urban expansion over time, and it is using our Sentinel-2 geomaps. Those are cloud-free mosaics that were generated from Sentinel-2, where we try to mask out cloudy pixels, replacing them by the median of clear pixels that have a continuous mosaic covering the whole continent, depending upon This is the derivation of was done on an annual basis, but you have 6 months geomads, even we have the monthly geomads for Sentinel 2. But this today we'll be using the annual geomads from Sentinel 2. So here in the background, we wrote the Sentinel data set. We create the ENDISI index. We define the threshold. Then we compare the baseline from the year of comparison. Of course, once again, uh, we what we do, we load our packages and we define creating a local task cluster. It's a way of making the task easier to our memory because it you kind of divide our study in different track, and then what it can do, it can process part by part, then reach it at the end. And of course, to use the urbanization as application. And of course, we should always be able to define our study area either using relative longitude and buffer, or even if we have a clear polygon, we can upload it and work on an exact area. So I will share the parameters into the buffer with you, the relative longitude and the buffer. I'll share it with you. You can even copy immediately and paste into that cell number 4 and run. And also I kept the year 2017 and 2020, but you can change to the recent years. There's no problem. It's just for demonstration. And when you view on the map, you see this is our political and diplomatic city of Abuja. We load our data sets, and after loading our data sets, we can uh, uh, visualize the true color uh, images for each year, 2017, 2020. Even visually, you can see that there are some differences. Then we can create our index. Then this is the visualization of our index from 0 to 1. Uh, and after what you do, we define our thresholds, this which is 0.33. Everything below minus 0.33 should be considered urban. You can compare the 2 years using our index. Then you can plot the change in the urban extent, and you can see how from 1946 to 2468. You see how the city has grown over time. Then you can do change detection. Once again, the urban decline, this should be a confusion between the bare soil and the metap areas. So if we have exact urban areas, you can mask out just to improve uh, the accuracy. So this notebook is free available, and what you can do, uh, even not only in our sandbox, but also you can go to the DAfrica GitHub uh, repository for those who are familiar with the GitHub, and then you can go to the road examples. We have this uh, urban change detection notebook. Then I can share the link with you. Yes, if you like to have a look. So if I go back, this the best way to monitor the urban change detection over time. But Also, there are several ways we can also use the radar data sets to understand the urban change over time. You know, that radar data are cloud free, and of course, they will um, always be suitable, be very useful for us to understand the urban change detection. And of course, we thank ESCA for providing access to this state and also access to road cover that could able to validate this product. And you can try to understand. This is the SA road cover, and this is the classification from level sets, and then it's a good way to show the road cover. But also, we can compare different indices that try to understand how each data, each index would match the classification of any urban areas, and of course, be able to decide which index is appropriate for any given area. In the case of Docker, using free index that was normalized difference built up index, the enhanced normalized difference to previous surface index, and finally, the artificial surface index. But also, there are other global data sets that are very useful within the Africa platforms. This resolution population density, AGK. Any question? Oh, thank you. And these are global data sets that provides approximately 50 meter spatial resolution population data. And they are very useful to understand the dynamics of populations across the continent. And do we think the providers that even gave a clear metadata, and you could compare young youth population, female population, percentage of youth and the female, a very well detailed data to inform several development initiatives. So those settlement footprint, of course, also at 0.52 degrees resolution, and it gives information about the global settlement for 2015. And of course, it uses math templates and then one, and then it's 8 optical strides. And of course, the footprint for 2019 also, it features Copernicus as in the one and in the two missions. That to try to understand the trend of settlements at global level. And now you're focusing on African continent. So if I go back to the sandbox, so I have talked about the urban change detection, but also I talked about the radar urban mapping. So this one is using um, the Sentinel-1 dataset, and or it is well described the rationale behind why do we need to understand the urban trends, uh, because it's useful for both uh, planning, but also intervention in terms of disaster risk and emergencies and so on. And of course, some images are not clear, especially optical images in tropical regions. That's why we should always try to use Sentinel-1, even radar. That means radar images that could penetrate clouds without any obstacle. Once again, these data are a little bit limited because they have a small temporal resolution, but also the spatial coverage is not full to that. Not every corner of the continent is covered at one date, even at different dates may vary. So we should work on combining the polarizations of these data sets just to understand how they can uh, reflect the urbanization. But this we use the unsupervised classification. You have to separate urban and non-urban. And of course, we try to validate this using the ESA word cover, where the class on a built up class was used just to cross-check the results of our classification. Once again, brought the packages. As I said, we try to create local dust cluster and connect to data key. We use urban area mapping. And of course, we define our study area once again. And if you can see, we are around Badan, in Nigeria. I can share the coordinates in the chart for those who would have to go together with myself, the same. And also the time range that should be from 2020 January to 2025 April. I see this is very different. So the location of the map, we can view it. Then uh, we can route our data sets, putting the query uh, subject, doing the resolution, and also uh, try to kind of to cut out the layer in different uh, chunks to easy the task to the memory, and also we have we have 159 time series, and then we can try to process read data sets that we can able to convert the DN to DB. This is the data process methodologies, processing methodologies. Then and compare the this is the vertical polarization, horizontal polarization compared to a vertical polarization in a DB. Can also compare in we can compare once again after processing, and then we can do advanced classification. K means the number of classes. So we try to compare. This is using two classes. It's using three classes, and it's using four classes. Then we went for the second one, and we read that the urbanization should be class number one, and that's why we be um, inside this class, and then we get urbanized and urbanized areas, urban areas. Then you can validate using the European Space Agency would cover 2020, and then this is the map for study area, the land cover map for the study area. Then what you can do, we validate using the class known as a build up. And then if you see build up class is the code is 50. That's why we'll be using it. We try to compare with our classification, then do create some accuracies uh, metrics, and then you can see over accuracy 37, F-core 51, accuracy, and so on. And then you can see that we have a lot of false positive and a lot of false negative. It makes sense as this map from ESA was smooth. So we need to kind of smooth the map to eliminate some issues that don't make sense to remain with the clear data sets. Once again, also we can also try to understand the word settlement footprint. As I said, Those are global data using Valink with one set from 2015, another from 2019. It's a way to try to understand the trend of urban areas over time. We loaded them in our database. Once again, we're working on Abuja. After loading our data sets, we can spread them the quality, then we can plot our data sets. As you can see, 2015 and 2019, you can see how Abuja has grown between those two uh, within 4 years, and even the direction of expansion. And then you can calculate the area using a property formula. And if you can see, Abuja expanded approximately for 68.6 square kilometer just in a period of 4 years. And you can plot the spatial extent, see some new buildings that appeared on that during that period. But also we can use what you call the settlement print, footprint, and evolution. Also, the data sets that combines several data sources uh, could help us to understand the uh, trend of urbanization in a given area. I kept the same uh, study area, which is Abuja. Then we can also view the location map. It should be Abuja, no problem. And then we have several ways, but we can once again see how this has been evolving over time. And also it has a score of precision. This IDC score means um, a kind of a measure of consistency. And the guys are saying that it's intuitive measure that account for the availability of information, the input data consistency. This input data consistency, the IDC score was built. It ranged from 6 to 1. 6 very good, fair, or 1 very low. So if you see in our data set, you can see that it's only 6, mean that the classification, data availability, and the consistency was granted for analysis, and also calculated the settlement footprint, and also plot them on a graph. And this we can also produce some animations that show us how our city has been evolving over time. It's Noza. Any question? Is that to raise your hand? Please unmute your mic and ask your question, even give your contribution. Thank you. Okay, this was something about urban change detection and settlement being near your time, but also tracing changes from the past, and but also we can understand the urban greenness. So urban green space and its recover. This was developed using a collaboration in the Sahel and West Africa labs. So, and the idea was to use global data, especially the Africa Police 2015 and 2020, to try to map out the urban, the African Police, just to define the urban extent, but also using the local space agency will cover maps to try to extract tree cover and even green spaces in urban cities. And this is a good way to monitor uh, the concept of green cities and how uh, um, cities or governments are complying with their commitments. And As the more green it becomes green, the more it attracts. It's environmental friendly and attracts more uh, residents. So, and the methodology for this was documented as you see per the paper. You can see on the the notebook. We import packages, also reader function or ACD. This means the Sahara. This is OECD, means Sahel and the West Africa crabs. And this urban green space, of course, specify a study area. I specified this was Abuja, Abuja, and then we did this general statistics for using our ESA would cover map. Then we proceed with data set. The most importantly that went into every step was not book exercise. It was to get the comparing 2021. We get the dynamics of each class. So you can see the cooperants because the surface went even outside the city. And now here is the tree cover, which was increasing over time. And also it can go down until we get something using the ACA or the cover map, something that able to compare urban green spaces while increasing in Abuja in 2020 and 2021, and the tree cover um, was equally increasing, and this becomes a good indicator that Abuja is more or less a green city, and I think that's why more international organizations look to stay in Abuja. So this is this was the urban settlement footprint, as I said, and also this was the case of Joburg, that increase of 113 square kilometer over a period of 4 years, a rapid growth compared to others. So the Nairobi, Kenya, increasing 50 to 50 kilometer between 2015 and 2019. The Dodoma, Tanzania, increasing equally. And of course, if we go inside Abuja, so that it includes Abuja, if we go back to Abuja in the notebook, or settlement footprint, I like that you see that Abuja increased by approximately 68.6 square kilometer, that over a period of 4 years. And we can go down this including the evolution. I said you can compare years from 1985 to 2015, and of course we can come up with a nice animation that shows us how urban areas have been evolving over time and how new buildings have been colonizing um, uh, either green cultural lands and even um, water in some areas of Nigeria. When I was exploring, I saw some buildings that were appearing in aquatic areas around Lagos City in Nigeria, and this could be detected using remote sensing, also once again JABAC method. But also to monitor environment, how the urban growth is affecting green the green areas, and if urban cities uh, are if urban areas are respecting the concept of green cities to avoid both noise, even air pollution. And that's why, in collaboration with the OECD, we try to develop this model that helps us to understand uh, the urban growth. So it's the Africa Police data that defines agglomerations like an area with more than 10,000 people, and buildings that should be closer, uh, not less than within less than 200 meter, and green spaces coordinated based on the Africa Police boundaries, and also use ESA or the cover to understand classify green spaces, and also we use you combined grassland trees and shrublands, and and of course to come up with the total green area. So this example of Africa Police datasets, as you can see, for this was the example of Joburg, but also when I was showing you in the if we go to into our area also, it can not only work on Joburg, but as you said, uh, we can for the Africa Police was worked in Abuja, and of course, uh, if we try to go, this was Bada, but you can still go to Abuja, and just on a click, they can give us all the description in terms of population, in terms of urban green spaces, urban tree cover, and all the information around, and that's this information helped us to just calculate all statistics about trees. And of course, this was a accurate tree mapping, and this was an example of Joburg, and also how tree stand was evolving over time. It is of was compare Kumasi equally behaving well, almost stable for both Kumasi and Nairobi. But if I go to Abuja, and as it is showing, you can see how the tree cover was evolving, and most importantly, the green spaces and tree cover were increasing in the city. So that was about the urban growth, urban expansion. And before I go to the second talk for the day, which should be the coastal erosion, just like to hear from you if you have any comments or any question, and otherwise I can continue with the second topic of the day, which should be the coastal erosion, especially the dynamics on the coasts. Any intervention, comment, question, feel free to unmute yourself and bring your intervention. I count from five, four, three, two, one. If nobody, then I continue with Gambo. Abraham, over to you.
Good morning, and thank you for the very educative session. Hello, am I audible?
Yes, please.
I have seen that almost all the maps.
So your voice is on and
The
off. Could you please type in
They
the
are being
chat?
made in the form of a
Sorry,
box.
Abraham. Sorry, Abraham. Can you type in the chat? I can't hear you very well.
Okay. Hello, am I audible now? Is it better now?
Yes, better. Thank you.
Can you hear me now?
Yes, yes, please. Yes, please.
Hello.
Oh, sorry. So, Blessing, how can I locate maybe a project you could not finish? I could, you could,
Yes, I've seen that the maps are all in the form of a box.
yeah.
Uh,
Yes, Abraham, I got your point. Let me try to answer your question if you allow.
Hello. Hello.
Hello, Abraham.
All
Okay,
right.
okay. Sorry for that. Actually, Abraham, you say the everything is in a box. It's oh, sorry. So Abraham, I can't hear you. Maybe
Yes, I've been wondering if I can use the actual map of my. Hello.
Abraham, yes, please. I get your point. Actually, it's a box because I've been using latitude, longitude, and uh, uh, and a buffer. But if we had a precise polygon, we should have used this uh, this function, define area of interest, and locate our vector or our shapefile just to define the precise area for our analysis. So it's really feasible if we have one boundary and this is the code we can use. And what you do, if we remove this one, it means that this code could be executed. But we've put it and frozen it so that you couldn't run the two at the same time. So please use this code to upload a share file if you have any. It's definitely really feasible. And someone asked if I can share this the the link to the sandbox. Sorry, I did it. Once again, I share. I thought everyone was already logged in. That was our Peter Len. How can you locate maybe a project you could not finish but saved? So if just if the sandbox is your account or my account is fully protected. Actually, you can't have access to my project unless I share it with you maybe on the GitHub. And in the sandbox, projects are not saved by users. We always keep the backup. Either you download on just on this, for example, let me check one example, one notebook here. Um, Maybe this one, you just right click, download, and you keep the version uh, within on your computer, or you can even what you do, uh, connect your account with the GT Hub and on via the Africa YouTube channel, there is way uh, way, there is a way where I can share with you the link in the chat. There is a tutorial on how you can efficiently use the D-Africa sandbox. I shall show the tutorial with you in the chat. It's a YouTube video. You can have a look at it and see how it can help to understand all this way of working with the Africa sandbox that can back up your work. So relationship between the sorry, secondly, what is the relationship between Lab into Africa map platforms? Actually, Lab is mostly about programming language, that kind of developing libraries that could work in the notebook, and it works always with the sandbox. While the Africa map platform, it's a web mapping in an integrative way. What they share on it, that sandbox and the map, we access the same data sets, but the potentials of what could be done in sandbox using these GPTLab notebooks is a little bit robust. We can do further processes. We have a cloud environment. We several work on the cloud. You can download, export everything, and so while the map is very exploratory interface. So, oh, thank you, everyone. So let's go to the second part, so that I like to be quickly quick on this, and this should be about the coastal erosion. And why you'd like to understand the coastal erosion? The African coasts are almost 60,000 kilometers on the African coast. We are facing several phenomena, including the coastal erosion, but also that phenomenon is affecting the coastal infrastructure, especially megacities like Lagos, and also ecosystems, especially the mangrove vegetation, is being affected. And that's why the Africa tried to develop several tools available in the sandbox. And of course, we tried to understand how we can inform trends on the coastlines, just to make sure that you minimize the impact of climate change, which is that of the sea level rising, even in the coastal erosion. So this tool, sorry, so this tool was developed with the CSC team in the Senegal and the RSMRD in Kenya, and it was validated. We can show the hotspot rates of change of a shoreline. That's very impactful in addressing climate change impact. We thank this team from Senegal, CSC, for the support in the validation of this service. And this tool was adopted by worker countries, and is a good way to monitor the trends of coastal erosion in the area. Available using map, the sandbox, in other ways. And this is an example how it looks like in a map. We can use QGIS, listed of Africa, West Africa, geoportal, and so on. So a lot of examples changed in Mozambique, in Madagascar, and also annual changes. And this was in Lekki, Nigeria, and you can go into the sandbox once, into the map, Africa maps once again. For example, if we go around Lagos, so Once again, if we try to zoom around we can road, go to the Explorer, um, explore, and you can go to the Africa coastlines, and this will give us a continental scale product that's showing the trend on the African coast where we have erosion and uh, or accretion, and then we can zoom to any area around Nigeria. So this is Lekki, and we can have a look at the coastlines, how they evolved over time, not only the coastlines themselves, but also when you keep zooming, you see year by year, and just on a click, it can show you this is a shoreline for 23. Then you can show raw data, and you can say this this is not the sustainability is not that high, but the tower is insufficient. It means that also when the PDX should be cautious, especially those dot lines. This is where especially the data was insufficient and it was not that good, but also at least we're going to go another. For 2017, if we check the raw data, we see that it was good. And here we can even download a table in terms of CSV or even Johnson format just for spatial analysis. So this also I can share it with you whenever you want, and you can have a look at it the same way I was seeing it. Once again, we can go to about the data, and the whole description of the coastline service is available via this document, how it was generated, what are the limitations and potentials, and what should be considered while using this service. And most importantly, you can once again be able to download the shelf files until 2024, going through this link I'm sharing with you right now in the chat. So once again, we can also understand the mangrove vegetation over time, try to understand their dynamics over time, and also create some change detection maps, graphs, statistics, and also maps. And then this is comparing the global mangrove watch datasets to the one we've produced. You can see that for this free town, the vegetation was more or less stable, comparing the appearance. The data change is higher. The change is higher. We had a lot of mangrove around Freetown in Sierra Leone. So once again, if I go back to the sandbox for the long vegetation, let's Okay. Sorry, once again, the connectivity is not that good at my from my office. Um, so I was trying to. I hope you can hear me now. Can you hear me?
Yes, we can hear you, sir.
Oh, great. Sorry for that. That was not good from my end. I was saying that you can go back to Nigeria around here by yourself, and you can load the data on vegetation, global mangrove watch. This is a global database on mangrove vegetation, and this was for I think 20. You can always save what data, and the recent one was for 2016, a little bit outdated, but using the Africa platforms, we can load uh, we can load our our geomads. When you go to the internet, you can load our geomads. And as mango vegetation, it's about NDVI. You can use the NDVI just to check out the mango vegetation for 1 year. Let's say uh, this should be this should be you can check from 2017, for example, and compare them with you can do a comparison and compare them with let's say this was 2017. You can compare with 2024, for example, and see for our area. This 2017, this 2024, 2017, 2024. You can actually say overall, now vegetation was getting restored if we compare this 2017, 2024. I think 2024, the vegetation year was behaving better. Then I can share once again this in the chart. And so if we go into the sandbox, there are a lot of ways to explore, but I go back just after the presentation. We're able just to map some vegetation in Zanzibar and try to inform some management practices. This community is currently restoring the malvegetation thanks to the information got using the Africa platform. I thank this Prof. Khalija Musud from the University of Zanzibar just for the support, and also they are currently still undertaking the same project. Also, going to Nigeria, we thank Jokotola who used Reachable Lagos. She was able to map the degradation and loss of mangrove, try to put it in the context of climate change impacts. And of course, she was able to inform through management and in that area, and this was in around Niger Delta, and she combined both water observation from space, our geomads, just to understand the change in mangroves and also the water appearance and disappearance over time. And the Africa maps, the coastlines have been showing this as you saw, and you can zoom to a spot and cold spot across the continents. You can zoom at any point and see if you get good data or not, as I've been showing. And also in the Africa sandbox, with those notebooks that prepare to monitor to correct the coastal erosion, even draw coastlines interactively using app-developed application. But most importantly, it needs workflow that could be part to draw a conclusion through a combination of Landsat Sentinel-2 datasets, those are optical sensors, and if possible, Sentinel-1 to come up with some areas of post-erosion hotspots for informed decision. So this was the lake in Nigeria. I was showing you the area, the coastlines, and see how for each year it has been behaving over time. And of course, you can use the coastlines to draw a translate to show us some statistics. I go back there. So this is a validation of coast erosion for reported in cooperation with the CSC team. And of course, there are several tutorials. And if I go back to the sandbox before I go to the dashboard, we can go into our DAfrica notebook in the DAfrica sandbox, load examples, and the notebook called coastal erosion that uses all these images, the Landsat Sentinel-2 and Sentinel-1, which is radar, and we can um, we can someone is asking question if these codes are purpose for training. Okay, I thought thank you Samuel. I thought as a login these codes are available via the sandbox. They are available as via the GitHub. Just for your daily or any use. So somewhere they are freely available to everyone. Like this sandbox, this coastal erosion codes, I can share the link with you. They are permanently available and you can enjoy them. You can adapt to them however you want. You can either specify only the your study area and run the codes. So this coastline service could help you just to not only to map everything, but the most important part we want to show you at time is flying is just to show you that using this workflow I've been presenting to you, you can come up with a kind of time series of the change. Water and non-water are derived from water indices, and then you can spend the time series. You can try the shoreline. Uh, I want shoreline for each year, and you can plot the shoreline on interactive map, um, and then you can even export this shoreline on a table of statistics, and then after uh, you can export the shape file just for your future use, but you can come up with a graph like this that show you how the post trends have been evolving, but also how this could, behind this, we have importantly statistics on the change, the rate of change per each year, even the quality of the shoreline that was generated as I was showing you a few minutes ago into in the sandbox. So lastly, just to show you what the last part of the presentation, we've developed a dashboard. The idea was that everyone should be able to understand the the change in coastal erosion, if there have been erosion in rate or accretion, will remain unchanged. For example, for Nigeria, 170 kilometer express the retreated, others are defaced, and of course, the affected population uh, within 1 kilometer was 1.1 million in 2021. But uh, people in flat areas were 176. That's the most vulnerable society was around 176.1 thousands. That was in 2021. So if I try uh, to share, uh, if I try to share the the dashboard with you in the chat, or even I try to load the dashboard for you. I shared you also in the chat just for you to explore. Sorry, this is the dashboard. I can share it with you in the chat. Sorry, don't share this in the right link. So you can see on the dashboard, we can not only when it's loaded, we can not to click on each country and see the level of the erosion or accretion, and also just for this for Ghana and the affected population. And this population in such areas are the most very vulnerable communities. So this was for Nigeria. Can you go for Sierra Leone? It just was for Nigeria, and can you go for Somalia? You know that Somalia is the one with the longest um, coast in Africa. But also, you can go any point here on this map. You can go to any point here. Just on a simple click, it will give us information on the coastline, and also some of the explanations that we're able to understand the service in the best way. And so we can go from one point to another. Like this one in red, they are mostly hotspots, while in blue, they mostly be cold spots. Uh, and this is the coastline in the dashboard for the coastline. And if you go back to our presentation, so we can access it via the Africa Geoportal in collaboration with S3. Please feel free to log in the africageoportal.com, and also lot of applications like this river Tungera in South Africa that produce the coastal vulnerability that inform the management of the coastal erosion in the area. So some work in Swatini, in Etwini, Durban, South Africa, was try to understand the population that's being affected, the level of the dynamics, the coastlines, and of course, to project in the future what should be, yeah, if extreme weather events occur over time, and how or which intervention or mitigation measures should be put in place. Also, there is some notebooks on the ship mapping that we're able to detect some presence of ships around the ocean, in the ocean, around the port, using Sentinel-1 data. And this was validated. It's a good notebook available in the sandbox. Oil spill, able to understand. Uh, this was the case of Mauritius. That was um, after the incident of 25th of July 2025. Over 1,000 tons of fuel was probably spilled into the ocean. And of course, we had to cooperate with the Ocean High Commission and be able to kind of map, let's see, before and after how it looked like to detect some areas that were affected by. by this is that. So I actually we should have a look always at our the Africa learning platform, uh, which is very key because if you go and type learn dot the Africa, we have if you type learn dot Africa, uh, you have our courses, several courses that are free available, and we equip you with them. And we have two many courses for the topic of the day. The first one is the coastline. This is available in English and French in the coastline. So it's a course that's very well described. So it has to develop and has uh, enough chapters. You can have view the course and start enjoying the content. So I can sign in so I can view it very easily. You just sign in, create your account, and enjoy the course. It's free at your pace. What you need is just internet. You can see this course it shows us how we can work using the Africa map just to understand the coastal erosion and the mangrove analysis and all other um, aspects of spatial analysis. And this course is one, but also we have others, especially the one on urbanization. We have a course on urbanization also available in French and English. So this was recently updated. So in the course on urbanization, you're going to see the course with several chapters that equips you with enough skills to with the African tools just to monitor both urbanization and the coastal erosion. And lastly, of course, our live session every week. Help desk to send us a ticket and our website. We thank everyone here, especially the Nigeria Space Research and Development Agency and everyone here. And please reach out to us when necessary. And once again, uh, don't forget to share your feedback and thoughts using this form I've shared in the chat. Also sent via email this morning, and of course, tomorrow, if you share the information, tomorrow I proceed the certificates by today, and tomorrow I share them with you. And once again, fast, but it's a kind of increase your curiosity so that tomorrow we want to develop use cases for everybody, and then we start supporting either a group of people one on one or even individuals or institutions who want to apply this approach in their daily life. So once again, question, please uh, to feel free to unmute yourself and bring your intervention. Thank you.